Welcome to this new video. I am your usual host Arya Chakraborty, and today at the end I will invite my friend Shoptoshi who will be joining today, and he will be demonstrating and he will be helping me to demonstrate the project named Parkify, which have been created by us in the Hack for Bengal hackathon. So let me just demonstrate you the project, and this is the official organization, GitHub organization, and you can access the repositories. For example, if you want to access the Parkify AI and means the Parkify AI part or the artificial intelligence part, you can go to the repository and you can clone this repository. I will actually edit the README and I will make it better so you can navigate through it very easily, and you can clone this project. You can do all kind of stuff with this boilerplate which you will be providing. And this is a very robust and very good application, by the way. Let me just show you that. So I will be demonstrating you the artificial intelligence part or the AI part or the ML part, whichever you want to say. So I will be demonstrating you that, and I will actually edit some of the PTH file, because these PTH files are PyTorch files, actually PyTorch model files. This contains all the weights and biases. This will be replaced by this .h5 files, which you will see after. I will link the this thing, this repositories and this organization in this comment section or description section, right? So after I do that, you will be able to see all these changes, and you can work on your own project, or you can actually create an issue and you can contribute to our project. That's what we want to say, and I will demonstrate it to you quite a bit. So let me just go to this main application. Let me clear my terminal first, because that's what I do. That's have been a habit for these videos here. Yeah. So what it actually does, so let me go through that first. And this get plate function actually extracts the license plate, or the license plate is nothing but a sequence of alphanumeric characters, right? So for example, if we look at this car, this HR26BP3543, if you notice a pattern, the first two characters are first two alphanumeric things are characters, and the fourth and fifth, no, one, two, three, four, five. Yeah, the fifth and sixth uh, things are characters. Only the zero and one position and this fourth and fifth position are stuck with characters, and rest are all numbers. So I have written an algorithm. For example, if the index is in 0, 1, 4, 5, then it will call the alphabet dot predict, and otherwise it will call this number dot predict. This num and this alphabet are nothing but this dot h5 files. This thing is just the path, and it will get into this model alpha, or this alpha thing, and this number model num dot h5 will get into this num thing. So yeah, that's the project. And let me introduce you to a new concept. For example, quantization. Yeah, so we have used quantization in this project. What is exactly quantization? Quantization is a process which reduces the number of bits, because every number or everything is represented in zeros and ones in computer hardware. So we are trying to reduce the number of bits which are not necessarily required. By not necessarily required, I mean that those bits do not contribute to the accuracy of this extraction of this number plate, right? So those bits, or the least significant bits, or the bits which are after the decimal point, let's say, those bits increase the precision. Those bits do not increase the accuracy. I hope you know about the difference between both of these words. And those bits actually increase the precision, not the accuracy. So we are using this quantization thing to reduce the number of bits and to reduce the cost, because if we reduce the bits, we will require less storage in the camera hardware. We will talk about that later. So let me just demonstrate you that this test card front is nothing but this image, and I will be running this script so that you will understand how this gets extracted. Right? Python main tab, enter. It will take 1 or 2 seconds, I guess. Let it see. Yeah, right now it's quite accurate. As you can see, this is the extracted number plate, and it's quite accurate. And yeah, this is our parkify model. So let me just go through this. Let me just, yeah, this thing. Yeah. So our USP is this deep learning model and this quantization and batch norm technique. This batch norm means nothing but scaling the values of the or the pixels between 0 to 1, because we know that if we don't scale our image, some of the feature might overpower other features. For example, the other things might overpower our actual license plate, right? So we don't want that. We want to get a license plate, not the type of the car or where is it from or anything else. So our main focus is license plate. So that's our USP. We are focusing on specializing on what we do rather than generalizing everything. By generalizing, I mean that we are not trying to detect every text which we show to the camera. We are just trying to implement the camera in such a way that it can only detect number plates rather than anything else, because that's what we want, right? And that's our product is. This is neural network model. Our advantages, let me go through it one by one. So our advantage is fair pricing. For example, if you want to go to a mall, you don't want to go into the hassle of finding parking lots, because some of the parking lots might be filled, some of the parking lots might be overpriced. So you can actually see transparently what are the prices of these parking lots per minute or per hour, anything you want. And you can also see what are the available parking lots or the vacant parking lots near you. So after that, the owners of the parking lot can also tell the world that they have the parking lot, right? So that's also one advantage. The other thing is that it does not have any manual intervention. So by manual intervention, I mean everything will be done by our cameras and room breakers and everything else. You do not need to have a security guard or a manager who manages the parking lot. You don't need that. Everything will be taken care of by the backend and our machine learning model. By machine learning model, I mean the cameras itself. So our machine learning model is very robust, very accurate, as you saw, and it's very cost effective due to the quantization thing, and it is also very seamless, as you can see, as I have explained it, right? And Shoptoshi will also explain it after this, while he demonstrated the backend. So why our solution is better? Because every other OCR, for example, Keras OCR or Easy OCR or PyTesseract, they are all either inaccurate or take too long. For example, I have tested it with Keras OCR, PyTesseract, everything. PyTesseract and this Easy OCR thing, they are very inaccurate, but the Keras OCR is very accurate. But the problem with Keras OCR is that it takes 15 seconds, which I don't think any customer will wait for 15 seconds to just um, take his or her car into that parking. So that's a lot of time, and we wanted to eradicate that. And the thing is, Keras OCR actually is a very generalized model. If you show it any text, it can detect it. But that's not our problem. Our problem is to detect license plate rather than anything else, right? So we wanted to be specialized. As you can see, we are focusing on specialization instead of generalization. So let me go to the next page. And this will be done by Shoptoshi. If you see the next demonstration of the backend, you can understand what this means.
Thank you, Arya, for the introduction. Now I'll just show you around the Parkify app and all of its features. So as you can see, we are at the Parkify app and we can sign in using this button here. This provides all the regular sign in and sign up features. We have already created some accounts. The accounts can be of two types: the ones who provide the garages for rent and the users who can avail the services. I'll just log in as a provider for once. As you can see that there are certain garages I have created. There are location features, latitude, longitudes, and we can edit all the stuff here, including the charge per hour. We can also create new garages using this form, and this is mostly the features on the provider side. Now moving on to the user side, we can there is first the profile stuff where we can already edit the basic profile details and all of the good stuff, and we can search for garages too. This uses our browser latitude longitude and gets the two of the closest garages near our current location. So we can also tweak this feature to make get better results, and we can go to the history. So this shows us all the billings that we have created or done um, in the past basically. So when a new booking is completed, like the number plate is scanned and the entry and exit, a new booking can be seen here. It contains all the details like garage ID, in time and exit time, and the total amount to be billed. If I create a new booking from here, like from my backend, and if I just refresh the page, you can see that a new booking has been added to the end of the page. So this is it.
The limitations, yeah. The limitations are, first of all, the accuracy. The thing I showed you, the image, it predicted accurately, but we don't know yet. We haven't validated yet for a lot of images, right? So that's a drawback of any machine learning model, I think, and it's not very accurate. But we are trying to introduce post-processing techniques, and you can see, right, we already have introduced some of the post-processing techniques to make our algorithm robust and very accurate. So we are trying to achieve that, and we are always trying to work towards that. And the second thing is, right now we don't really have our cameras ready. After we acquire some hardware person, we can actually have the camera ready as well, and it will make this product very good. Yeah, it will launch this product actually. What we think of right now. Right now we have just simulated through a Python script, but that will not happen because Python is a interpreted language and it can't be translated in hardware. In a hardware, if you want to run a program, you have to write it in C or C++ or Verilog or those sort of things, right? And yeah, that's our limitations. Our future scope is to introduce those post-processing techniques, those probabilistic measures which we want to take, and we also want to incentivize the user. For example, if a user is very honest or have a better rating, we will think about that, those rating part. He or she will get some discount on that parking lot. So yeah, that we are thinking right now, but that's not a very important thing for us right now. Right now, the important thing is to implement this on the hardware level, which we are thinking right now, because that's a revolutionary thing, right? And so yeah, thank you for tuning with us, and hope you liked our project. And we will be there with a new project soon, or maybe this project in a better manner. So thanks for tuning with us, and keep supporting us. Bye.